Hello my dear friend, welcome back again in the new video of Power Learning channel. So in today's video we will see important electrical interview question and answers. So let's get started. This video will help you in your interviews. So watch it carefully. If you have any question, comment us below. Why star delta starter is preferred with induction motor? So the question is why we are using star delta and why it is preferred to use star delta starter with induction motors. So we see now star delta starter is preferred with induction motor due to following reasons. So there is several reasons. So first reason is starting current is reduced 3 to 4 times of the direct current, due to which voltage drops and hence it cause less losses. Second reason is star delta circuit comes in circuit first during starting of motor, which reduces voltage 3 times. That is why current also reduce up to 3 times and hence less motor burning is caused. The last is, in addition, starting torque is increased and it prevents the damage of motor winding. So now we will see the next question. So the next question is, what the difference between generator and alternator? As we hear both terms generator and alternator in our daily routine life, and sometime we get this question in our interview that what is the difference between generator and alternator. So generator and alternator are two devices which converts mechanical energy into electrical energy. Both have the same principle of electromagnetic induction. The only difference is that their construction. So we will see now what is the difference in their construction. Generator persist stationary magnetic field and rotating conductor. Okay, in generator we have stationary magnetic field and rotating conductor which rolls the armature with slip rings and brushes riding against each other. Okay, so in generator we are using slip rings and brushes which riding against each other, hence it converts the induced EMF into DC current for external load, whereas an alternator has stationary armature and rotating magnetic field for high voltages but for low voltage output. Rotating armature and stationary magnetic fields is used. So you understand the difference between generator and alternator. So now we see why AC systems are preferred over DC system. Why we are preferring always AC systems in our daily life and even in electrical energy. Why DC system we are not using? So due to following reason, AC systems are preferred over DC system. So what is the point number A? It is easy to maintain and change the voltage of AC electricity for transmission and distribution. So what we understand that AC is easy to maintain and change voltage of electricity for transmission and distribution. So B is plant cost of AC transmission circuit breakers, transformer, etc. is much lower than the equivalent of DC transmission. So the third point is, from power station AC is produced, so it is better to use AC and then DC instead of converting it. When a large fault occurs in a network, it is easy to interrupt an AC system, as the sine wave current will naturally tend to zero at some point, making the current easier to interrupt. So that's clear. So now go to next question. So the next question is, how can you relate power engineering with electrical engineering? So in this question we will see what is the relation between power engineering and electrical engineering. How we can relate? Is there any difference or no? And what is the difference between power engineering and electrical engineering? So power engineering is a subdivision of electrical engineering. Okay, the power engineering is subdivision of electrical engineering. It deals with generation, transmission and distribution of energy in electrical form. Okay, it deals with generation, transmission and distribution of energy in electrical form. Design of all power equipments also comes under power engineering. So power engineers may work on design and maintenance of power grid, therefore called on grid system. They might work on off grid system that are not connected to the system. So now see the next question. What are the various kinds of cables used for transmission? So what are the different cables we are using for transmission? So cables which are used for transmitting power can be categorized in three forms. So low tension cables which can transmit voltage up to 1000 volts. High tension cable can transmit voltage up to 23,000 volts, and super tension cable can transmit voltage 66 kV to 132 kV. Okay, the next question is, what are the disadvantages of low power factor and how can it be improved? So now we will see the disadvantages of low power factor and how we will improve the power factor. So the disadvantages of low factor: line losses are 1.57 times unity power factor. Larger generator and transformers are required. Low lagging power factor causes a large voltage drop. Hence, extra regulation equipment is required to keep voltage drop within prescribed limits. Greater conductor size to transmit or distribute a fixed amount of power at fixed voltage. The conductor will have to carry more current at low power factor. This required a large conductor